Well, hey guys, we're not on campus this week, so I thought I'd spend a little time talking to you about how you're going to work, how I need you to work through the lab today. Well, this week. So today we're looking at volcanoes, but specifically volcano geochemistry. So I need you to go through the notes um, this week. One of the key things being understanding the relationship between different styles of volcanism and the different chemistries that come with tectonic situations, such as divergent boundaries and convergent boundaries, and specifically, mostly silica content. But we're also going to look at some other isotopic ratios. So when you open up the lab today, which is down here, it's a Word document. I'm going to be submitting a new version of this with some alterations, but you're going to need to do a couple of things. One, you're going to need to download something called Geomap App, which you can go to geomapapp.org to download. You simply go to the download links here, whether you're for your particular platform. You can also go to previous versions if you need to, but you need to download that. That program looks like this when you open it. Well, I've already got some data input, but it basically is a map. It does a lot of really cool things. It's so exciting. But anyway, you're going to be uploading some data into it. Now, that data, there are certainly versions of it here, but what you need to do is go, and the lab will take you through this. You're going to go in the lab. You're going to go to the beginning here, and you'll go to Geomap App. There's a link here. There's also this link to earthchem.org. And when you go to earthchem, you're going to go to the main page, which is here. You're going to go to the earthchem portal, and then you're going to go click on search earthchem portal, and you're going to search based on a polygon region. So you're going to go and set by location. You're going to use a polygon, not a bounding box, but so then you'll click on the define polygon. And specifically, you're going to be looking off of the western coast, southwestern coast of Mexico, and then up here in the Cascadia region. And I'm going to show you how to gather the data for one of these locations. Okay. Now, if you go to the lab, it tells you exactly how to create your box for that one and for this one. So I'm going to do roughly the same region here. So we're going to make it Washington, Oregon, and then off the coast here. And then you have to double click on the last one. Now you'll notice that when I'm going across this region, I'm including the Cascade Mountain Range, so the Cascade Volcanics. I'm also including a subduction zone along here. I'm also including, you should be able to clearly see the spreading center with the transform boundaries also in here. So there's quite a bit of diversity of volcanics here. If I hit submit, it'll take a few moments, but it'll take you to a page where I can begin to specify what I want to download as far as data is concerned. So these are the different databases it's referencing. Okay, so you can see it's all data that's submitted by researchers. And so this is kind of a data repository. So you're using archived data that somebody else has already used for research. This is actual data. That's really cool. And then you just click continue to data selection. Again, this is all in the lab instructions. You can do a lot of things here. You can plot various specific kinds of diagrams, TAS, Harker diagrams, things like that are kind of cool, and for the geochemist, pretty useful. I'll show you what a Harker diagram looks like here, which is usually these are different chemical species against one another. But you know what? It's going to take a little while to do that. We're going to click on Get Chemical Data. I only have so much time with these videos. I'm using a free app right now for this, so got to keep it under 10 minutes. If we go and get the chemical data, incidentally, when you open Geomap app, I'm going to go ahead and close this so I can reopen it for you. I've got it already locked and loaded, so to speak, here. I'll open that bad boy here. And there's my data, by the way. So when I get here, it'll tell you to, before you click Go to Data, you're going to go and download as a text file. You could download as a spreadsheet, but you want it as a text file because you have a text file to import into Geomap App. Go ahead and show units. Good to have. You want all the major oxides. Those are already all marked. You want to clear everything else. Simplify your lives. And then under the isotopic ratio, you want the strontium 8786 and the neodymium 143, 144. Those isotopes are very specific for looking at various certain tectonic processes, which will come to play later on in the lab. Once you've done that and you have everything ready to go, you click Go to Data. While it's pulling that up, I'm going to go ahead and oh, you don't need to look at my screen resolution. Oh, Geomap App didn't come up for me. What's going on here? Run. Okay, so then I'll hit agree on this. And once I do that, it automatically pulls up the Mercator map, and that's the important thing for you guys. You can do a lot of things, a lot of really great. Please experiment with the buttons and have some fun. You can do some interesting profiles and things like that. We're going to be looking again specifically at the Cascadia region. To zoom into that region, we would click on the zoom button and then drag a box over it. There are already a bunch of data layers that you can look at, and the newest version is a little different than what the lab talks about, but basically the same. So what we're going to be filing, we're going to be importing a table or a spreadsheet. We're going to do that. It's going to be an ASCII file that's tab delimited, and then I haven't downloaded my data yet, or I did download it. It came up down here. It's already been downloaded in my downloads folder. So now I'm going to go ahead and in Geomap App, I'm going to go find my downloads folder, and it's all alphabetical. So once I get past the folders, I'm going to look for something that starts with Earth Chem, because that's the automatic default file it creates. Here's my file, Earth Chem download, and it automatically knew what to pull in. It's formatted just the way it needs to be, and then I can hit OK. And then I need to specify a few things. I want to make sure the latitude is latitude and longitude is linked to the longitude column. I don't need to worry about these two columns. I do need to adjust my point size to 50% because my symbols will be too big otherwise. But once I do that and I hit OK, it'll say, wow, you have 26,000 records. Just go ahead and plot all records anyway. And that's my records. Now I'll ask you to do a couple of things. One of which is to color your samples by silica content, and you can drag down here and grab silica SiO2, and then to do this, you see it automatically colorizes things. I'm going to drag these bars over so that I can get as wide a color range as possible, and then you'll start to see some trends pop up. If I zoom in a little further here, even you'll see that the Juan de Fuca spreading center is very consistent in terms of the blue dots. Has a whole lot more diversity of composition in terms of silica content over here. So remember, silica content's important. Lower silica content means less explosive volcanoes. Higher silica content means more explosive volcanoes. So let's see if I can get the graph to work. It wasn't working for me earlier just because I was doing something wrong here. Oh, okay, we're not gonna get a graph. But anyway, I have some things I can fix to make that work on my computer, but you may not have any issues. Let's hope you don't. That'd be one area where you could. But anyway, so you can see there's a whole lot of diversity of composition over here and not so much over here. So this is important already. But you can make graphs and you can color in different ways. This is your actual data is down here. So there's all your oxides. Your isotopic ratios are over here, and they don't become important. There's only a few data points for the isotopic ratios. So anyway, in the lab, you're going to be answering some questions, and you're going to want to create a page where you can answer the questions. It does give you some things to talk about, some things to think about. So anyway, important to note here that you have this exercise here, and then you have to repeat it. So please follow all the directions. I'll be looking for all of them when you make your graphs. So, all right, good luck, enjoy, and I'll see you next week. Send me questions and email if you have any.